All right, so we're now moving on to our next section, section C, and that's going to be compound events. In this video, there's a decent amount of terminology that you're going to have to know and how to apply as well. So at the end of this, make sure you are looking back at your learning objectives and checking off that you have at least a basic understanding of them, or starring it if you need me to go over in class, next class. But what you'll need to know by the end of this video is, well, what is a sample space? And when we're dealing with these sample spaces, there's a few different ways that we can actually show them, and that's by listing it and writing it out. But we're also going to learn a quick way of figuring out, well, how many will we have in our sample space by the fundamental counting principle. So that will allow for us to figure out the total number of outcomes much quicker than listing them out. And then the next terminology you're going to have to know is you're going to know, well, what is a compound event? And then the last thing is going to be, you'll have to be able to list all the possible outcomes in a compound event. So you'll need to know what a compound event is and how to list them. All right, this video is going to mainly be going over just a couple key terms, but then mainly examples. I think there's 5 examples we're going to go through in this video. So make sure you're writing them down and paying attention. And if you need any help with any of these, you're unsure, make sure you're writing down your questions so you can come into class with it. All right, so the first thing we're going to talk about is sample space and the set of all possible outcomes of one or more events. So before we're only talking and looking at just one event, now we're going to be looking at one or possibly more. And all those possible outcomes is referred to as a sample space. So even in the questions we did before, I can say list all the provide the sample space, and that's telling us that we're listing all the possible outcomes, even though it was just one event. That's fine. But the sample space is all the possible outcomes that can happen. And now we're going to start focusing on when there's more than one event as well, not just one event. And there's a few ways that we can do this. We can use a table, or we can use a tree diagram to find the sample space of 2 or more events. So when we have just more than one, we then need to figure out all the different possibilities, and we can use a table. And if you've done a Punnett square before, it's very similar to that. Or we can list a tree diagram. I'll show you both ways, and once you see both of them, you can decide which one you want to use. I'm not going to force you to use a table or a tree diagram. I will probably use a tree diagram every time, because when we get into where there's more than just 2 events and there's 3 or 4, the table can be a little bit harder to use. But when it is just 2 events, the table is maybe a little bit easier actually, and it's something that we'll be using in algebra next year, so it could be good for you to see. But you can decide which method you want. But when it's more than 2, then I definitely would say the tree diagram is the better way. All right, so now we're just going to go ahead and get into some examples, I believe, right now. All right, so it says find a sample space. You randomly choose a crust and a style of pizza. So we're not picking what we want, we're just randomly doing it. Find the sample space and how many different pizzas are possible. So the sample space is all of the possible outcomes. So when we're getting something like this, when it is just a few examples like we have here, we maybe could figure this out in our head, that we can have a thin crust that's Hawaiian, a thin crust that's Mexican, a thin crust that's pepperoni, and so on. But you're going to be dealing with more than just 2 different choices and 4 different choices. So you might be dealing more than that. So it could be beneficial for you to create a table or a tree. When you are doing this, I will expect to see one or the other when you're showing me your work for this. So when you create a table, what you do is you're going to create a table where you'll list all of your possible outcomes in your columns or in your rows. So in my row here, I'm going to list all my different styles. I'm going to list H for Hawaiian. I'm going to list M for Mexican. I'm going to list P for pepperoni and V for veggie. And then in my column, I'm going to list all my different kinds of crust. So I have thin crust or I have stuffed crust. So to figure out what we can do, well, we can have a Hawaiian, that's a thin crust. So this HT, we fill in all of these boxes by just making the combination of the row and of the column and the row. So here we can have a Mexican thin crust pizza. We can have a pepperoni thin crust pizza. We can have a veggie thin crust pizza. And then as I move on to my stuffed crust, I can have a Hawaiian stuffed crust. I can have a Mexican stuffed crust, a pepperoni stuffed crust, or a veggie stuffed crust. So this is listing out all my sample space and all the different possible outcomes. When we're drawing a tree, what we do is we start with one of our choices that we have. And I like to start with the one that has more options first. So I'm going to list all them out. I have the Hawaiian, I have the Mexican, I have the pepperoni, and I have the veggie. And then from here, I'm going to list all the possible choices with my crust. So from the Hawaiian, I can have a thin crust or I can have a stuffed crust. From my Mexican, I can have a thin crust or a stuffed crust. From the pepperoni, I can have a thin or a stuffed. And then from the veggie, I can have a thin or a stuffed. And then to list all my possible choices, I start with my first option and I just go down all the branches. Here, this one generates a Hawaiian thin crust. This one will generate a Hawaiian stuffed crust. And then I move on to my next option, which is Mexican. And this one will give me a Mexican thin crust, a Mexican stuffed crust. My next one, pepperoni, will be a pepperoni thin crust, a pepperoni stuffed crust, and my last one will be a veggie thin crust and a veggie stuffed crust. So you see, when we create these branches, following each branch or pattern that we have will generate all of our possible choices. So in all these cases, we have 8 or 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different possible pizzas. And then you would list all these out. So we would write out all these different sample spaces to say all of our possible sample spaces. On your test, I'd be okay if you just write it in a table or write it in your tree for now as well, as long as if your abbreviations are correct. And like if there were 2 styles of pizza that had the same letter, make sure you're differentiating between those letters. Now, the next thing we're going to talk about, and I just want to keep on the same page so that way we can make the connection, is the fundamental counting principle. And this just allows for us to quickly and easily figure out the total number of possible outcomes. If an event M has M possible outcomes, so in this case, let's say that our crust was our event M. Well, that has 2 possible outcomes. So the crust had 2 outcomes. And then our next event N, in this case, we'll say is our style, and our style had 4 outcomes. Well, before we go to figure out how many we have, we can identify, or listing them out, we can identify how many. And what we can do is we can multiply the total number of outcomes of the 2 events. And 2 times 4 will give me 8 outcomes. And that tells me how many possible outcomes I have. All right, so the fundamental counting principle is we look and see in all of our events, how many outcomes do we have? And then we say, okay, we list all the possible outcomes or all the possible events. And then we just multiply those numbers together. And that tells us how many total outcomes we can have. So even if there was a third different event on this, meaning if we wanted sauce, or I guess here sometimes people use Thousand Island dressing. So if we want to talk about the different kinds of sauce that we can have, we can list that as another event, and we can multiply all those together to figure out how many different combinations we can make. So the fundamental counting principle, instead of having to list all these out to figure out how many, is we can figure out the number of outcomes for each event and simply multiply them together. So by multiplying our 2 outcomes in our different events together, we saw that we had 8 different outcomes, and we knew that already based on our table or our tree. All right, so now let's go ahead and move on to some other examples. All right, so for this one, it says find the total number of possible outcomes. So all they're saying is find the total number. It doesn't say we have to list anything. So you don't actually have to list all the possible outcomes. You can just tell me how many. All right, it says find the total number of possible outcomes. So find the total number of possible outcomes of rolling a number cube. Let's just go ahead and assume it is a 6-sided cube and flipping a coin. So if I want to find the total number of outcomes, well, my 2 events, I have rolling a die, and I have flipping a coin. Well, in my die, I have 6 outcomes, and flipping a coin, I have 2 outcomes. So if I want to find the total number, I can simply do 6 times 2, which is equal to 12. So I have 12 total outcomes. All right? It doesn't say to list. It doesn't say you have to list anything. So since it doesn't, we don't have to. Now, if you wanted to, we can create our tree diagram and list all of our possible outcomes of our die. And then we can go ahead and say, okay, from each of these numbers, I can roll a 1 and flip a heads or a tails. I can roll a 2 and flip a heads or a tails, roll a 3 and flip a heads or a tails, and so on. And that will then allow for me to generate all of my possible outcomes. And I can say, okay, I can roll a 1 and an H, a 1 and a T, a 2 and an H, a 2 and a T, a 3 and an H, a 3 and a T, a 4 and an H, a 4 and a T, a 5 and an H, a 5 and a T, a 6 and an H, and a 6 and a T. And I can go ahead and count all them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I could list them if I need to, but it doesn't tell you that. It just says find the total number. So that means we could just simply use our fundamental counting principle to figure out how many total outcomes we have. All right, so for this next question, and this is where it's important for you to be able to understand what we're actually asking for when we say how many versus list all of them. So this says find the total number of possible outcomes as far as our question, but when we read the question, it says how many different outfits can you make from the t-shirt, jeans, and shoes in the closet? It's saying how many. So all we want is the number. It doesn't say to list all them out. It doesn't say what are the different combinations or list all the different combinations. It says how many. So by seeing that, that means that we're looking for a numerical answer. So what we can do then is just look at all of our different events. Well, we have jeans. Well, our jeans, we have 4 different possibilities that we can have. Then we have our shirts. So our shirts, we have 1, 2, 3, 4, 5, 6, 7 different shirts that we can have. And then with our shoes, we have 1, 2, 3 different shoes. So if I just want to know how many based on our fundamental counting principle, we just multiply these numbers together. 4 times 7 times 3 will allow for me to know how many. It won't tell us all the different combinations, but it will tell us how many we can have. So 4 times 7 is 28, and 28 times 3 is going to give me 60, so then 84. So we have 84 different outfits that you can wear based on our fundamental counting principle. All right, so make sure that you're aware of what the questions are asking. If it said list them, then this would not be your full answer. You would actually have to say all the different combinations, green jeans with gold shirt and white shoes, etc. So you'd actually have to list them all out. How many is this saying? Give us the number. So all we needed to do is just apply our fundamental counting principle there, and we were done for this question. All right, so the next thing we're going to talk about now is a compound event. And a compound event consists of 2 or more events. So before we were talking about sample spaces, a sample space we could use when it was just one event still, but it could be used for 1 or more. Now when we're talking about a compound event, we're specifically saying where 2 or more events take place. So a compound event is not just a singular event. Picking or rolling a die is not a compound event, but rolling a die and flipping a coin would be a compound event because we now have 2 events that are happening. So a compound event is 2 or more events. And as with a single event, the probability of a compound event is still the ratio of the number of favorable outcomes to the number of possible outcomes. So you're always going to hear me say favorable or what is it that we want to happen over the total number that can happen. So it's still the same thing, but now when we're talking about a compound event, we're now going to have to focus on more than one event that is happening together. All right, so now I think there's 2 more examples we're going to go through with this, and then we're done with this video. All right, so for this problem, it says find the probability. So once again, once you see probability, we know that we're going to go our favorable outcomes over the total. And we're going to give this answer as a decimal or as a percentage. So in example 2, which is what I wrote out here, so I listed all of the outcomes of rolling a die and flipping a coin. It says, what is the probability of rolling a number greater than 4 and flipping tails? So you see this word and. That means they both must happen together. So it must be greater than 4 and flipping a tails. So I don't have to worry about any of these outcomes here because none of these are greater than 4. So none of these will satisfy that first constraint that we have. So now we look and say, okay, both of these will allow for me to be greater than 4, but it needs to be a tails that is flipped. So that means these are the only 2 outcomes that are greater than 4 and a tails. So my favorable outcomes in this case is I have 2. I have 2 outcomes that can happen that we're looking for, right? And then we have 12 total outcomes that we have. So it then becomes 2 over 12. And remember, I do want this written as a decimal or as a percentage. So you will go ahead and put this in your calculator, which is equal to 0.167 or 16.7%. So the probability of rolling a number greater than 4 and flipping a tails is 16.7%, which we would say is very unlikely to happen. All right, and I think this last question is the last one, and this video is over. All right, so the last question we're going to go through is finding the probability of this compound event. We flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? So for this one, remember, since it's probability, we need to do our favorable over our total. Now we can figure out our total number of outcomes pretty quickly because we have 3 different events. We're flipping 3 different coins. And in each of these events, we can get 2 different options. We can get a heads or a tails. So if I want to know my total, I just simply multiply all the possible outcomes of my events, and 2 times 2 times 2 is 8. So I know that I have 8 total outcomes. right? So now when I go to do this probability, I know it's going to be over 8. Where this can get hard is we need to figure out, well, how many times can we flip 2 heads and 1 tails? So we're going to go ahead and actually list this out. So the first event that we have, we can flip either a heads or a tails. And in each of these events, now drawing these branches is listing the second event. And in all of these cases, we can get a heads or a tails. But we're flipping it a third time. So in all of these, we're going to have a third event, which means we now will have a third branch coming out. And all of these, we can get a heads or a tails. So now, when we're listing these out, I see that this one is H, H, H. So that means that they're all heads. Here we have H, H, T. So we have heads, heads, tails. Here we have H, T, H. Here we have H, T, T. Here we have T, H, H. T, H, T, 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 H, and T, T, T. So all of these are now all the actual events that can occur when flipping all 3. So now what we're looking for is where we have 2 heads and 1 tails. It doesn't say order matters. So here's 3 heads, so that one doesn't count. Here we have 2 heads and 1 tails. We have 2 heads and 1 tails. We have 2 tails. We have 2 heads and 1 tails. And then for the rest, we have at least 2 tails. So we don't have any other that work. So there's 1, 2, 3 different favorable outcomes. So now we have our 3 favorable outcomes over our 8 total. So this will then give us 0.375 or 37.5%. And that will be our probability, which we would say is somewhat unlikely to occur. All right, that is it for this video.